Hello, everybody, and welcome to our Scientists in Action Looking for Life in the Universe. My name is Anna. I am the bilingual program coordinator here at the Denver Museum of Nature and Science, and we have a really exciting program coming up. Before we do that, we want to go through a few housekeeping items. First of all, our school that is on camera, we will ask that you stay muted for the duration of this program until it is time for Q&A, at which point we will call you up for questions. Even if you are not on camera, you will get a chance to ask questions too. You can feel free to put those in the chat at any point throughout this program, and we'll try to get to those during the Q&A. But otherwise, please remain muted so that we can go through our program. Now, before we actually start, we do have a question that we want to ask while we're still getting ready here to start. And that question is, what allows life to exist on Earth? So go ahead and type those answers in the chat here. Take about 30 seconds to answer what allows life to exist on the Earth. So I'm seeing some great answers coming in already. So air or oxygen, plant life and water, oxygen, we agree with water. So great, those are some great answers. And now I am really excited to introduce you to our speaker today. Dr. Chun Yu is the space science curator here at the Denver Museum of Nature and Science. Chun, please take it away.
Yeah, thank you very much, Anna. So welcome, everyone. I'm glad to be there virtually with you today to talk about life in the universe, or looking for life in the universe. As Anna says, I'm the space science curator, and what that means is I am actually an astronomer here at the museum. I do research on star formation, and I use our digital planetarium quite a bit. And we will actually be using digital planetarium software to help us explore life in the universe. As you can see, I'm actually controlling where we're flying. This software uses observations and data collected by thousands of astronomers using telescopes, both on the ground and in space. And so everything that we will be seeing is based on real science, real data. Nothing is made up. And thanks, everyone, for contributing to the chat about what you think helps support life on Earth. And we can see a lot of those answers in this view of Earth behind me. So there are a lot of people answered water, or chose water as what was important. And obviously, we can see water in the clouds, the white clouds swirling over Earth's surface, as well as in the blue oceans. People mentioned the air. The layer of air is pretty thin compared to the bulk of the Earth. You can barely make out kind of a fuzzy edge to the atmosphere on the right side of the Earth. But the air does provide oxygen for us and other animals to breathe. And that oxygen is created by plants. And plants require carbon dioxide to grow, and they produce oxygen as a byproduct. And so both those gases are actually extremely important for life on Earth to survive. Now, I want to mention one other aspect of life on Earth, and that is the fact that we live on a planet that orbits the sun. And so here you see the Earth and all the inner planets. We can see the orbits of the outer planets. But I'm also going to turn on this green band that shows what's known as the habitable zone, or the Goldilocks zone. And you can see Earth in the middle of that, and Mars is on one edge of it, and Venus is on the inner edge. And this Goldilocks zone shows you where in space around our sun that it's warm enough or cool enough for liquid water to exist on the surfaces of rocky planets. So if you're too close, you're too hot, the water will boil away. If you're too far, you're too cold, and the water will freeze. And what we know is that on Earth, water is essential for life. Wherever we find water, we find life. And so we think of the surface of the Earth as especially habitable, or a place that where life can exist. But one of the discoveries that scientists have made in the last 50, 60 years is that there are actually places on Earth that are habitable to life that we don't normally think is conducive to life. These are places that are very extreme. These extreme environments are places that you wouldn't want to visit or live necessarily, but we can visit them. And so we actually have a poll right now, and you get to decide where we go next on the Earth. We want to visit a place to look at extreme life, in a place where you can actually go and see, or a place that's very difficult for you to see, or if you want, do you want to go see both?
Let's take about 30 seconds here and decide where do we want to go next here on Earth to look for extreme life. Wonderful. It looks like we want to visit both.
Okay, well, we're going to go visit both. So I have the Earth behind me again. And what we're going to do is we're actually going to fly down into North America. And I live in Denver. Denver Museum is also obviously in Denver. But we're going to go to Yellowstone National Park. This is about a 9 or 10 hour drive from where I am. And if you've never been to Yellowstone, I definitely encourage you to go. You can take a road trip with your family during summer vacation. This is a wonderful place to visit. It's full of animals like bison and wolves and elk and deer. But the other amazing thing about Yellowstone is that it's full of hot springs. There is water that's bubbling up that's been heated by very hot rocks inside the Earth, underneath the Earth's surface, and they fill large ponds or pools. So we're coming up on a spring called Grand Prismatic Spring. You can see how colorful it is. And there's actually a walkway that visitors can stand on because otherwise there's boiling hot water all around you. So I'm going to land inside this 360 image that I actually took when I visited a few years back. And you can see the water in this pool is extremely clear. But what you don't notice is that you don't notice any visible life. You don't see fish. There are no frogs or amphibians. There's not even really any algae. And you can see steam boiling off in the distance. I'm going to turn around. You can see other visitors on the walkway. And I'm going to look towards that colorful pool. And again, we don't see any other signs of life. But the reason why there are these colorful colors, you have oranges and reds and browns up close, and then it fades to yellows and then greens and then blues off in the distance, is that there are bacteria here that have evolved or have learned to live in this very challenging environment. And so there are different bacteria that result in the different colors. And even though the water is boiling hot, you can again see the steam that's rising off in the distance, and no other life that we would normally associate with can survive here. These bacteria do absolutely fine. And I think we even have a picture of that bacteria. This is an electron microscope view. You can see each of these sort of cylinders is an individual bacteria, each of them a single-celled organism. And what we think is that early life on Earth might have arose in similarly harsh environments because the early Earth was extremely hot. It probably had a lot of places that had boiling hot water. And we think that early life might be very similar to these extremophiles, these bacteria that love these extreme environments. And so since you wanted to see both places, we're actually going to go and travel to one other place and turn off the atmosphere. And we're going to go, here's Hawaii that we're passing by. That's the island chain in the center. And then we're going to come down. There's Australia off to the left. And then now we're going to see Japan off in the center, and China and the rest of Asia off to the far left. But we're going to zoom down to the Pacific Ocean, and we're headed towards the Mariana Trench. So this is this trench contains some of the deepest parts of the ocean. You can't get any deeper than parts of the Mariana. But we're going to go not in one of those super deep parts, but just off to the side. And we're going to see a video taken from researchers who work for the National Oceanic and Atmospheric Administration, and they piloted a remotely operated vehicle, an ROV, from on board their ship. You can see them controlling it, and they're down at the bottom of the ocean to visit these hot smokers. So you can see smoke that's coming up from the bottom. It's superheated water that's boiling hot, but that water contains nutrients and other elements that bacteria can feed on. So that bacteria forms the base of a food chain down here at the bottom of the ocean. So we're so far deep that sunlight doesn't penetrate, so there isn't any normal plant life, but those bacteria that live off of this boiling hot water is fed on by other animals, by larger critters, and so on. And so that's why you can see shrimp and crabs and even weird-looking fish, which we'll see in just a second. And even though that central, those plumes are extremely hot, the water at the bottom of the ocean is extremely cold. And so that means these other critters are swimming around in pretty lukewarm water. So it's actually pretty temperate. It's pretty comfortable for them, but they don't want to get into the super hot water that's shooting up. So this is another example of an extreme environment on the Earth that we didn't used to think life could survive. But here we have an example of life thriving in a place that's very extreme. It's not a place that you can easily visit or would want to visit because it's so dangerous. But it shows you that life can find ways to live in places that we wouldn't think that life should live in. So that brings us to our next question. Now that we've seen some of these places on Earth, where can we go elsewhere in the solar system where we can search for life? Now, I'll tell you right off the bat that we haven't found life outside of planet Earth yet, but we are interested in looking. So some of the places that we can look are the planet Mars, an icy moon that a spacecraft is flying to right now, or an icy moon around the planet Saturn.
Great. Take about 30 seconds to answer where you'd like to go next in our solar system. Wow, it looks like we have a three-way tie. Going to the planet Mars, the icy moon the spacecraft is flying to right now, and the icy moon around the planet Saturn.
All right, well, we'll go through these quickly then, since everyone wants to see all three. But behind me is the planet Mars. Mars is known as the red planet, and as you can see, it's very different from the Earth, which is what we've been looking at. There's no obvious oceans, no obvious bodies of water. It's a very heavily cratered surface, and so we don't think that life can really survive on the surface anymore. But what's really interesting is that if we fly down to the surface, and scientists first realized this when they started seeing imagery sent back from spacecraft, is that Mars contains signs of past water. So even though there's no visible water on the surface today, you can see channels. So you can see a big channel that runs up and down, north to south, and it's connected to smaller channels that go off to the sides from east to west. And some of these channels run into craters and they run out of craters. So we think Mars was wetter and warmer in the past. And since life arose relatively quickly on Earth after it cooled off enough for Earth to be habitable, people wonder whether Mars similarly might have evolved life very early on, and perhaps there's fossil evidence for life still on the surface, or perhaps if we dig deep enough, there might even be actual life on Mars. So what I'm going to do is I'm going to switch to a different satellite view, and what we're doing is we're zooming down to Jezero crater, or Jezero crater, and even as we are at this crater, we're about 3,000 kilometers up. You can actually see a couple of river channels, one going off to the upper right corner, and then there's also one kind of in the center and to the left of this crater. We're going to go to that central left one. So this is signs that a river, possibly filled with running water, once ran over the surface of Mars. It carved through the crater wall, and then if you follow this river, you can see what looks like a big amount of mud that spilled out from the river, and it kind of splashed out and then froze. And then there's some craters that formed on top of this, almost like a river delta. And so currently there's actually a Mars rover, one of our robotic explorers that's on Mars. This is a picture of Perseverance that the rover took of itself. So it's a selfie from the rover. And you can see how dry and desolate Mars looks. There's a bunch of rocks on the surface, as well as a lot of dust. The rover is covered in dust because Mars does have dust storms. But the rover is currently there to look for chemical evidence for life. And now the rover is about the size of a small car, so it's pretty advanced, but obviously it can't have every single conceivable scientific instrument. But scientists are using the rover to fill sample return jars that would be picked up by another spacecraft in the future. And so, by the end of this decade, we will hopefully be getting some of those samples back. And let's go on to our next world, Jupiter. And what I'm going to do is we're going to focus on the moon Europa. And this is the moon, and this is the planet that we currently have a spacecraft that's flying to right now. So the Europa Clipper was a mission from NASA that launched just a few months ago, and it's flying to Jupiter, which will take a few years. And it will be orbiting Jupiter, and it will be taking a lot of close flybys to Europa. And I'm going to go ahead and turn off the nighttime side. And Europa is a moon about the size of our moon, but the surface of the moon is completely covered in ice. And you can see lots of cracks on the surface. And what we think is going on, and we even have a diagram showing this, is that underneath this crust of ice is actually an ocean of water. And so just like on the Earth, where the heat from the Earth can leak out and cause boiling water to exist on the bottoms of sea floors on the Earth, we think, we can show that picture. Underneath the icy shell of Europa, there's an ocean that could be twice as much water as all the oceans on the Earth. And you can see at the bottom of the picture, there's some hot rock underneath the surface. And you can also see some hot vents, just like the vents that we saw on the Earth. And so we think that this ocean probably exists, and we definitely want to explore Europa more, not only with the Europa Clipper mission, but even future missions to explore that ice and to, perhaps even look for sprays of water to see if life might have evolved on Europa. And then finally, let's return to open space again. We're going to go to the planet Saturn, and we're going to now focus on another small moon. This is a moon called Enceladus. And like Europa, Enceladus is another icy moon that's completely covered by water ice. But what scientists discovered on Enceladus are these cracks that they call tiger stripes. So you can imagine a gigantic, fantastic tiger beast clawing the moon, causing these stripes. And what we think is happening with Europa is also happening with Enceladus. And we also have a cross-section picture that we can show where Enceladus has a shell of ice very similar to Europa, but underlying that shell is and I don't see the picture on my view, so I don't know if it's going out or not. There we go. There's a liquid ocean of water underneath, and through cracks in the ice, some of that water is actually getting out and spurting out into space. And so the Cassini spacecraft, which was another NASA mission, was able to take pictures of that. It even flew through those plumes of water. So Enceladus is, again, yet another place that we're interested in exploring more in our solar system, just because it's another place with water, and where there's water on Earth, there's life, and we want to know perhaps whether life might have evolved on Enceladus. All right, so with that, let's now turn our attention to the rest of the universe, to the rest of our galaxy. We've been looking at planets and moons in our own solar system. What I want to do now is we want to look at other planets outside of our solar system. So I've now turned on points or these blue rings representing all the planets that we've found so far. And for this next poll, we're going to decide, or you will be deciding, which planetary system that we will be traveling to next. So do we want to go to the closest actual planet to our solar system, so the closest solar system to us, a solar system with 7 planets, or do we want to visit a binary star system, 2 stars that are orbited by planets?
Great. Take about 30 seconds to answer this last poll. What planetary system should we visit next? Great, so we have a clear winner here. We want to visit the planets orbiting around a binary star system.
All right, let's, we'll slowly travel to that planet or that planetary system with a binary star system at their center. But as we are doing that, I want to show a video that shows you how most of these planets were found. It turns out that we don't just go and take pictures of them because it's actually very difficult because the central stars are so bright. It's actually hard to see the planets, but we tend to detect planets indirectly. So one of the methods is to wait for a planet to cross in front of the star. So we can't normally see the star itself because it's so bright, far away, but we can see the amount of light coming from the star dip as the planet passes by. So when you have a small planet passing by, there's a small dip. If you have a larger planet that passes by, you get a larger dip. So you get an idea of how big the planets are. And so if we go back to our planetary visualization, we're going to fly away from our solar system, and now we're going to fly through the thousands and thousands of planets that have been discovered so far in our galaxy. And the count is close to 6,000 planets that we know of in our galaxy. So that's 600 times more planets that we know of outside of our solar system than that are inside of our solar system. So that's pretty amazing. But what I'm going to do now is we're going to focus on one of those systems, and we're going to fly out to Kepler-47, which is a circumbinary system. And what that means is that there are 2 stars at the center, and those 2 stars are orbiting each other, and they're also being orbited by 3 planets that orbit much further away. So there are 2 stars. There's a brighter star that's a G star, so it's similar to our sun. And then there's a smaller star, which is a red dwarf, which is a much less massive and cooler star. And so you can see those 2 stars are orbiting each other via gravity. And as we pull away, we'll also see the orbits of the 3 planets. And we can make time go faster so that you can see all the planets orbiting relatively quickly. And it turns out that the middle planet is a Neptune-sized planet, and the other 2 planets are about 2 to 3 times the size of the Earth. So they're all planets larger than the Earth, and they it turns out that they're also inside the habitable zone, meaning they're too hot for liquid water to exist on the surfaces of the rocky planets. So with that, I think, Anna, I think it's time to turn it over to the schools and find out what questions you have for me.
Yes, wonderful. So we are going to go to Garden County Schools to see if you have any questions. And remember, when you ask a question, tell us your name and try to speak as loudly and clearly as you can to the microphone so that we can hear you well. I have a question. Hi, my name's Emmett Russell.
But
My question is, do you have any alien skeletons?
do we have any what?
Alien skeletons?
Alien skeletons. Well, unfortunately, the answer is no, although I'd love the answer to be yes. Like I said earlier, we have not found any evidence for life outside of planet Earth, outside of our home planet. And so that means we haven't found any evidence for intelligent life, whether it's communications from other alien life or any physical signs or skeletons. And we haven't found any evidence for more simpler biological life, whether it's fossils or bodies or chemical evidence or evidence in the atmospheres of planets. So unfortunately, this is why we are interested in looking, because we think, given our experience with the history of life on Earth, we think life on Earth started pretty quickly, soon after Earth became habitable, became cool enough for life to exist within a few 100 million years. And so we think those conditions could be replicated elsewhere in the universe. So that's why we're excited to try and explore both our solar system and outside of our solar system to look for life elsewhere. Thanks for that question.
Great question. Garden County Schools, do you have another question for us? How many stars are there?
How many stars are there? So that's a really good question. So I'm going to fly us away from our solar system, or the TRAPPIST-1 system, or Kepler 47, that's where we're at. And we're going to turn on some more exoplanets. So these are additional dots showing exoplanet candidates. And so you can see that there's thousands and thousands of possible planets or known planets, but they still make up just a small fraction of our galaxy. So this is an artist's conception of what our galaxy looks like. It's based on our best data, so it's as scientifically accurate as we can make it, our Milky Way galaxy. And just in our Milky Way, we think there are about at least 200 billion stars. And right now, we're finding many, many planets around those stars. And so we think that there are probably, based on the statistics of what we've discovered so far, there are probably hundreds of billions of planets in our Milky Way alone. And then, of course, there are many hundreds of billions of other galaxies throughout our universe. So there's definitely lots of planets probably that are out there to explore. That's a great question. And do you have time for another question from the same school, Anna?
Yep, we have time for a couple more questions from Garden County. Are there any planets like Earth in other solar systems?
Yeah, that's a great question. Are there any planets like Earth in other solar systems? And we do find, like I said, we haven't been able to easily take pictures of planets. So you can't take a picture and compare it to the Earth and say, this looks like the Earth, it doesn't look like the Earth. What we can do, like we saw in that animation, is we can get a rough idea of how big each planet is. And so we do find planets that are Earth-size. And some of those Earth-sized planets do orbit within the habitable zones of their stars, meaning they orbit just right, not too hot and not too cold. But we also find lots and lots of planets that are much bigger than the Earth. In fact, the most common type of planet is actually a planet that's about 2 times the size of the Earth. So anywhere from 2 to 4 times the size of the Earth. And so, right now, there's a lot that we don't know about all these planets. Since we can't take pictures of them, there's very limited information. And so that's why astronomers are interested in building new telescopes to learn more and to explore more about these other worlds. Wonderful question.
We have time for more questions. Is there unknown objects in space or the...
Wait, can you repeat that? I couldn't quite make out your question.
Is there unknown objects in space or the universe?
Are there unknown objects in space? Here, is that the question?
Yeah.
Okay. Yeah, I mean, astronomers are constantly discovering new things that they don't quite understand. And we've been talking about planets, but there are lots of weird astronomical phenomenon that we're still trying to figure out. So recently, I was reading an article about these super small galaxies that astronomers didn't really understand, and they were only discovered last year using the James Webb Space Telescope. They're super small, maybe only a few thousand light years across, but they're very far away, and they're also extremely red. And so they call them little red dots. And astronomers are still trying to understand that this new class of objects. But I suspect as we learn, just to get back to the topic of this presentation, as we learn more and more about planets and about moons, we will constantly run into things that we didn't know. So it was a complete surprise when we visited the planet Saturn and we sent spacecraft to the planet Jupiter to find these moons that had oceans underneath them. I mean, that was completely unexpected. So I suspect the more we learn, the better the telescopes we build, the more spacecraft that we send out, the more information we'll get, but also the more surprises we'll learn about as well. That's a great question.
Wonderful. We'll keep taking questions from Garden County.
Good. How many solar systems have you discovered?
Can you repeat that question? Was it how many planetary systems have we discovered?
Yeah.
Okay. Yeah, so there are actually websites out there that try to keep count of all of the planetary systems that have been discovered. And what we're seeing visualized here, all these glowing dots represent both ones that have been confirmed. And so those are the blue rings. And let me focus at the center, back on our solar system. And then the green and yellow and red dots are the ones that have not been confirmed. So if you go to one of those websites, I was looking at a NASA website just yesterday, and it said that we've discovered over 5,800 planets that have been confirmed. And there's probably at least double that number if you include all the unconfirmed ones. So so we're talking about well over 10,000 planets, either confirmed or unconfirmed. And those numbers continue to grow. It turns out that planets, we didn't actually know about planets outside of our solar system, or we didn't have the technology to discover them until about 30 years ago. So when your parents were little kids, maybe the same age as you were today, they perhaps didn't know of any planets outside of our solar system. So it's really only in the last 30 years, in one generation, that we've gone from 0 planets to almost 6,000. And we continue to discover more and more planets every week. And so if you keep track of those numbers, you'll expect those numbers to keep growing. That's a great question. Thank you. Do we have another question from the school?
Yeah, we can keep taking questions from Garden County.
If there is any life, where would it be?
Okay, can you repeat that? If there's any life, I couldn't quite hear.
If there is any life, where would it be?
Where will we look for it, or where we?
Like within our solar system, that's most likely.
Okay, so where in our solar system would be most likely? Is that the question? Okay. All right, so let's jump back to our solar system. And it turns out that the places where we expect life are ones that we have already visited. So Mars is one of the places. So even though life isn't there, we don't think life can exist on the surface of Mars today just because of the ultraviolet radiation from the sun. We think Mars was warm enough and wet enough for past life. So we're interested in exploring Mars to look for evidence of that past life. It could be fossil life, or maybe life survives deep underground in Mars where it's still warm because of hot vents where liquid water can exist. And then we've also gone and looked at a moon of Jupiter, Europa, as well as a moon of Saturn, Enceladus, where we think that the chances of life are also good just because there's evidence that they have liquid oceans underneath. And we are sending the spacecraft to Jupiter now, and we hope to send more spacecraft to Saturn in the future, or some scientists hope to. And then it turns out that those are not the only places. There are actually other moons around both Jupiter and elsewhere in our solar system. There are icy moons that also have hints of liquid oceans. And so, again, anywhere that there's water, we think life is possible. And so really, there are a number of worlds in our solar system where we think liquid oceans exist, either on the surface, like on Earth, or perhaps deep underneath the surface, and where life could have evolved and might exist today. So that's a wonderful question, something to think about.
Yeah, wonderful. We'll take one more question from Garden County Schools.
Oh, all right. There you are.
How big can the solar system get?
This question is, how big can the solar system get? Is that your question? Okay. All right, let's go back and look at our solar system. And I'm going to focus us on the sun again. And so if we look at our solar system, you can see Jupiter's orbit in orange and then Saturn's orbit. So Saturn's about 10 times further away from the sun than the Earth is. And Uranus is about 20, and Neptune's about 40 to 50 times. And in addition to the planets, we also have asteroids and comets. And so you can see just how many cometary bodies there are. And all these objects orbit the sun, and the further away you orbit, the slower you orbit. So some of these objects orbit very, very slowly. But you get a sense that this solar system, at least this inner part of the solar system, it is roughly about 100 times the diameter of Earth's orbit. So, so if you think about how big the Earth is as it orbits the sun, about 100 times it is what we're seeing. But it also turns out that there are even more comets even further out. And I don't think I have one of these other orbital, these comet clouds loaded, but there are even more comets that are even further out that are orbiting the sun. So depending on how you define the solar system, whether you define it for just the planets, or whether you want to include the inner comets, or whether the outer comets, the solar system can actually be really, really big, quite big. And it's not really changing size, meaning it's not necessarily growing any larger. The objects orbit in the orbits they do. They don't. The orbits don't change. The orbits might get altered as by gravity. As I can see objects orbiting now, but the orbits more or less stay roughly the same for the planets, and the comets and asteroids, their orbits could get altered by if they pass by another body like a planet. But for the most part, they all continue to orbit the sun. So the solar system isn't going bigger in size, nor is it shrinking. But thank you for that question.
Great. We're going to switch over to the chat now. We have a great question, which I think you will enjoy answering, Chun. What are you most excited to discover in space?
What am I most excited to discover in space? Well, I think, since I'm an astronomer and I don't actually study planets, so I'm not a biologist or a planetary scientist, so I learn more about planets out and galaxies and stuff beyond our solar system. So as far as topics concerning life, I think what I'm most excited about is the possibility of learning about the atmospheres of planets. So if we can show that animation again, showing how planets transit their stars, we see that this is one of the ways in which we can detect planets. But if you think about it, if a planet has an atmosphere, some of the starlight will go through the planet's atmosphere before it reaches us. And so what we can do is we can observe the star with the planet in front, in which case we'll get some starlight going through the atmosphere, and that atmosphere will absorb some of the starlight. And from that absorption, we can actually figure out what the atmosphere is made out of. And so we have telescopes today, like the Hubble Space Telescope, the James Webb Space Telescope, and even some other telescopes that have been used to do this experiment where we try to sample the atmospheres, where we try to detect the chemicals that make up the atmosphere of these distant planets. And what's really exciting is that if there are chemicals or molecules that are there because of life, you might be able to detect those molecules. So you don't actually have to travel to these planets to look for life. You can actually look for what they call a biosignature, a signature in the atmosphere that's from life that tells you life exists. And so the telescopes that we have today are just barely able to do this, and they are not quite suited for detecting some of the molecular species that we hope to find, but future telescopes will be able to find these tracers of life in the atmospheres of planets. So that's a really exciting opportunity.
Great, thank you. And one last question. Why is it important to find life outside of our Earth?
Okay, that's a wonderful question, and I'm really happy that someone asked that. And so, you might wonder, why should we care about life elsewhere in the universe? And I think part of that answer is that, we are a pretty curious species, and, we like to find out whether, and to use science to find out how the universe works, how the Earth works, how life works. And a lot of the technology that we use today, the fact that I'm able to talk to you remotely from the Denver Museum of Nature and Science is due in part to scientists working and making new discoveries about physics, about electricity, about how to make computers work. And similarly, you might think that there are no, real reasons why we should try to search for life elsewhere in the universe. But I think the answers to that question are very important, because we know that life evolved relatively quickly on Earth, or at least bacterial life did. But it took a long time, more than a billion years, for more complicated life to arise. And it took longer still for even more complicated and intelligent life to evolve on the Earth. So we think that life might be very common in the universe, or at least bacterial or single organism type life. And if we find evidence of that by looking at biosignatures in the atmospheres of planets or using other techniques, then that will be pretty exciting, because that tells us that the conditions for life are very common, and that we would expect life to be found in a lot of places in the universe, in places that we expect, as well as places, more extreme places that we might not expect. Now, conversely, it might be that we don't find any evidence of life at all. And that could be kind of a bummer, but I think that is also really exciting as well, because what that means is that life is actually very rare, and that it's very precious. The fact that it evolved perhaps only once in our galaxy and on planet Earth means that our life is very rare, it's very precious. We should try and take care of it. We should try and take care of our home planet and to preserve it so that life can continue to prosper and to exist. So I think either answer, life is everywhere in our galaxy, or life is nowhere in our galaxy except for one place that we know of. Both of those answers are pretty exciting, and both of those answers, I think, can make us really think about our condition and how to approach ourselves and our world.
Wonderful. Thank you so much. If you want to take a minute to give a final message to our students here.
Yeah, I do, Anna. So hopefully, after this presentation, you've kind of seen that, the search for life in the universe involves not just astronomers and people using telescopes, but what we saw with the hot smokers and the hot springs in Yellowstone, it involves also biologists and chemists and geologists who study these environments where we find extreme life. It involves engineers that make the equipment that allow people to research underneath the sea or to sample these extremely hot environments. So if you're interested in science or technology, there are many opportunities to learn about or to continue to get schooling in, or even to have careers in learning about life on Earth and elsewhere. And the other exciting thing, and this it follows up on an answer that I just gave recently, is that there are new telescopes that are on the drawing boards. So we have a video that shows possible ideas for what NASA calls the Habitable Worlds Observer, and this is a future telescope that's being planned right now, and it won't be launched for at least another 15 years, which means at least the year 2040 at the earliest. But what that means is that if you want to become a scientist and you're interested in looking for life outside of our solar system, by the time you finish all the schooling that you would need to get to become a scientist and you start working, this telescope might have just launched, and you can be one of the first scientists to use it to look for the signatures of life in the atmospheres of other planets around other stars. So I think it's an exciting time for science and for young scientists to be involved in looking for life on Earth or elsewhere in the universe, or really studying any part of the universe.
Wonderful. Thank you so much, Katrina, and thank you everybody for joining us today. We're so happy that you were here today, and unfortunately we are out of time. Before we go, I do want to plug, we are going to have our next Scientists in Action on February 20th. It's going to be about super sauropods and fantastic fossils, and I'm really excited because we are going to have a session in Spanish. So if you're interested in doing that, I hope you join us on February 20th. Thank you, everybody. Goodbye.
Bye, everyone.